All right, hello Algebra 1 honors. Yesterday we were working on 8.5 using intercept form, and there you have it written out using variables in there. Well, we started learning about it, and I talked about how x-intercepts are the same thing as zeros. And the reason it's called intercept form is that when a quadratic function is written in intercept form, you can get the zeros relatively quickly by using the zero product property. And oftentimes people will skip setting each factor equal to 0, and they'll just go, once they have an intercept form, they'll just go straight to the intercepts there. We also talked about how the 2 has no bearing on the intercepts because it divides out when you set y equal to 0. So anyway, that's what we're working on. We started working on yesterday, and let's continue with it. Let's look at our next example here. It says find the zeros of g of x. Now, I debated on whether or not to include this because actually this is not a quadratic. See how it's x squared and then you got x? If you were to multiply this out, you would end up with x to the third power, which if you recall is a cubic. But the same ideas apply, and in algebra 2 we're gonna do a lot of graphing by getting the zeros and things like that. So what we're gonna do here to find the zeros of g of x, excuse me, my goodness. Right away you could do the zero product property and set x minus 2 equal to 0 and x squared minus 25 equal to 0. But I think that I should remind you that you can factor this out further. This is kind of partially factored, okay? And it's not technically intercept form at all. The x minus 2 is done, it's good. But this is a difference of 2 squares. And the pattern for difference of 2 squares is awesome. Now you don't have to use the pattern. You can just think of two numbers that multiply together to make negative 25, but add together to make 0. And you would be thinking of 5 and negative 5, and you could go and you would have your factors that way. But the difference of 2 squares is pretty awesome. Square root of x squared is x. So that goes there and there. Square root of 25 is 5. And it's always 1 plus, 1 minus. Now, because we're getting zeros, I can put a 0 out front. And then I can set each one equal to 0. And I'll get x equals 2, negative 5, and 5. And it's good to remind you that these are actually coordinates. 2, 0, negative 5, 0, and 5, 0. This is kind of cool because when you actually learn to graph cubics in algebra 2, you'll, well, I can give you the whole story, I guess. You'll plot these zeros. And then you're going to do something called, you're going to look at the end behavior. And that'll tell you where to start on the graph, if you're going to start up high or start down low. And based on if you start up high or start down low, that'll tell you the shape of the graph. And cubic functions actually have this kind of snaky shape, which is kind of cool. But that's more than you need to know. All right, some other applications for intercept form is that you can write things in intercept form initially and then rewrite them in standard form. So in bold here I got it is possible to write a quadratic function when given intercepts or zeros. And exactly what we're going to do is we're going to look for the zeros and we're going to write intercept form first, then multiply it all out to get standard form. So on our first example, write a quadratic function in standard form whose graph passes through negative 9, 0, negative 2, 0, and negative 4, 20. Well, which ones are the zeros or the x-intercepts? You can look at what we wrote above, and I think it becomes clear. These two right here are the zeros because their y value is 0. This negative 420 is an extra coordinate, and we've talked about using extra coordinates to help us get what we need to know in a previous section. But we're going to start out by saying, all right, y equals, I'm not sure what the a value is, but I'm going to have, now here's the thing, we're going backwards, so notice, let's look at the example above. When we had 2, what was our factor? It was x minus 2. When we had negative 5, it was x plus 5. And when we had 5, it was x minus 5. So we're going to go backwards. We're going to have x plus 9, x plus 2. Pretty cool, huh? Now, class, if we didn't have this last point here, and it just said write a quadratic function in standard form whose graph passes through these points right here. Turns out there's a lot of different equations that would satisfy that. But they would have these two factors in there, but you might have different a values. So if it didn't have this negative 420, we could put a 1 there and call it good. You could actually put any number there and it would be fine. Couldn't put another x there, that would be wrong. But you could put any number in there and it would satisfy the question or the directions. But since we're given that negative 420, we're going to be able to accurately solve for a by temporarily putting negative 420 into our equation and then solving for a. So we're going to go 20 equals a, negative 4 plus 9, negative 4 plus 2. We'll simplify it down. We'll get 5, negative 2. Multiply that together, we'll get 20 equals a times negative 10. Divided over, a is going to be equal to a negative 2. From there, I can write out most definitely my accurate intercept form. So it's going to be negative 2, x plus 9, x plus 2. Oh, in class now might be a good time to mention the a does the same thing that a does in vertex form, in standard form. It can tell you a lot about your parabola. This parabola is going to open downward, and it's going to have a vertical stretch. It's going to be a little bit narrower. All right, unfortunately, we're not quite done here. This is intercept form right here, but what did they say they wanted? Standard form. So we need to multiply this out. Now, class, when you're multiplying, you don't distribute. Now, what I mean by that is, if I want to start out by multiplying this negative 2, it would simply multiply with the x plus 9, and then we would take that result and multiply it with x plus 2. You don't take the negative 2 and do it to both of these. That would get you too much. I'm actually a fan of doing the binomials first. And yeah, class, we're going to do the whole arrow thing. We're going to distribute it out. But I want to do a little bit of that in our heads, okay? X times x will get you x squared. Now, before I write what the middle term is, I kind of want to think it through. I'll get 2x, but then I'll have to switch over to multiplying the 9, and I'll get 9x. Well, 2x and 9x is 11x. Saves me a step. And then 9 times 2 will get me 18. Distribute that negative 2 across, and we'll be in standard form. Negative 2x squared minus 22x minus 36. What do you guys think about that? Let's do a couple more here. Write a quadratic function in standard form that has x-intercepts of negative 1 and 1. Well, class, x-intercepts are the same things as zeros. So we'll go y equals a, and then it's x plus 1, x minus 1. You do the opposites, not that it matters on this one. Notice, class, that's all they gave us. So since that's all they gave us, we can make a anything we want, but let's just make it 1. So we'll just replace it with 1. And then we do need to multiply this out. Now, this is actually a difference of two squares in reverse. So I know the middle stuff's going to go away. I actually know I'm going to get x squared minus 1. Okay, if you don't believe me, though, you can multiply it out. You'll get x squared minus x plus, and then multiply it out. X minus 1, those are gone. Y equals x squared minus 1. So just to summarize, no extra info. If they don't tell you anything other than the x-intercepts or the zeros, they don't tell you another point, they don't tell you any more information. So if there's no extra info, I actually don't want to put a parentheses there, no extra info to help, that's kind of awkward. No extra info to help solve for A. If there's no extra info to help you solve for A, just use negative, just use 1, okay? In reality, you could use anything you want, but it's more common to just use the 1, make it easy on yourself, because you don't have to distribute it out at the end, so why would you make it more difficult? Okay, so let's flip it over. Write a quadratic function in standard form that has a vertex of -3, 2. Well, this is thrown in here just to keep you on your toes. We've been doing intercept form in this section, but this one gives us a vertex. So are these zeros? No. Well, don't forget that you've learned how to do this. So you can go y equals, and because they give you a vertex, you're going to do vertex form. So it'd be a, and then you go x plus 3, right? You go opposite, x plus 3 squared, and then the minus 2 is the upward and downward shift. So it was shifted left 3, which makes us do plus 3, and down 2, so we just do minus 2. So we're going to do vertex form. No other information given, so we're going to make a just a 1. And then we do need to multiply this out. So some of you may recall there's a pattern for squaring a binomial. It goes square the front, in the middle you multiply them together, and times by 2. So you'll get 6x, then you square the back. Still got a minus 2 there. Simplify it like so. And bam. So again, this didn't use intercept form, but it's just a reminder that if you're given the vertex, you can still do the same sort of problem, just using vertex form first. All right, this next one is a little bit different, but it's actually pretty much the same. Write an equation in standard form represented by the graph. And you look at the graph and you notice that you're given what? X-intercepts or zeros. So you can go y equals, you can work backwards. It'll be, we got a, and then we got x, and it'll be minus 6, right, from there. And x minus 10, working backwards. Do we have any more information to help us solve for a? You bet we do. We got an extra point right there. So we'll go -2 equals a, and then we'll go 8 minus 6, 8 minus 10. We'll simplify this thing. I'm going to get -2 equals a times -4, divide by -4, divide by -4. We get a is equal to 1/2. We're not done yet, are we? We want to write this as 1/2 x minus 6, x minus 10. That's intercept form, but what are they requiring of us? To write it in standard form. So we're gonna have to multiply this all out. I like to leave the 1/2 until the end. So I'll do 1/2 and then x squared, and then it'll be negative 10x, and then I'll multiply this and get negative 6x. Well, together that's negative 16x. And then negative 6 times negative 10 is positive 60. And distribute the 1/2, and I get 1/2 x squared minus 8x plus 30. That's a standard form right there. Okay, check this out. 21 through 35, 45 through 49, 57 through 59, and it's odds. I think that'll be just the right amount of work, of practice, to get you ready for a quiz that we'll probably have on like Tuesday of next week. Yeah. So also I should mention, we're looking at, after this set of notes, we're going to have one more section, and then we'll be ready for a test. So we should shoot for a test next week sometime. Also, I believe next week we'll need to, next week we'll do a practice EOC. We'll also do just a little bit of review of some older topics. I don't usually do a lot of review because honestly, a lot of what we learned we keep using throughout the year. But expect a little bit of like maybe one review handout. Also taking some time to get familiar with the testing setup. Expect that next week as well. So we're gonna wrap up this chapter and prepare for EOCs next week. All right, thanks for watching.